Whale carcasses take decades to fully decompose and can provide food for an entire ecosystem on the dark depths of the ocean floor. Decay sets in soon after the death of a whale as the insides begin to decompose. The animal then expands with gas and sometimes floats up to the ocean's surface, where it can be scavenged by sharks and seabirds. Eventually, the ocean giant will begin to sink, falling kilometer after kilometer until finally coming to rest on the seabed. Whale falls can nourish an entire ecosystem of deep-sea creatures, from large scavengers to microscopic bacteria. They provide inhabitants of the mostly deserted ocean floor with a sudden and immense source of food. The death of a single whale brings a bonanza of nutrients to the barren waters of the deep sea, delivering an organic parcel equivalent to thousands of years' worth of marine snow. When a whale, elephant, seal, or any large animal falls, it supports a range of fauna, from tiny bacteria and potentially even viruses to mobile scavengers like sharks and hagfish, creating an ecosystem that can survive for decades. When a whale dies, the scavengers, including squat lobsters, sleeper sharks, and crabs, rip apart the flesh in a feeding frenzy that can last a decade. The horror movie stage, as marine biologist Adrian Glover of London's Natural History Museum puts it. As bits of soft tissue rain down, bringing a pulse of nutrients, a motley entourage of opportunistic worms, mollusks, and crustaceans move in. A single whale can provide animals with sustenance for up to 2 years during this initial scavenging stage. A natural whale fall is a rare sight, so scientists have few opportunities to study whales that have died and naturally sunk in the open ocean. Whale falls that are observed by scientists are usually dead, stranded whales intentionally sunk in a particular location to be studied in detail. Adrian says the death of a whale leads to a whale fall on the seafloor. Only a few whale falls have happened across naturally, the rest have been from sinking experiments. Large scavengers may reduce the carcass to a pile of bones, but there is still plenty of food left for some much smaller diners. Sea snails, bristleworms, and shrimp devour any remaining scraps of blubber or muscle. They will also eat organic matter that is emitted from the carcass. The animals accumulate in numbers around the whale, says Adrian. They will move in and grow to adulthood there. It becomes an entire population. Adrian explains these are the most important animals responsible for the process of breaking down the bones. Also known as bone worms, these invertebrates chemically eat the bones, breaking down elements such as collagen and fat using specialized methods. Additionally, they push oxygen into the bones, a process which speeds up decay. The worms, such as Osedax muciflorus, a name which literally means bone-eating snot flower, bore their bacteria-filled root system into the bone, leaving their feathery plumes waving in the open water, taking in oxygen. Deep in these roots, the worms and bacteria make acid and enzymes to break down different elements of the bone. Some Osedax males live on the outside of the female's tubes, fertilizing eggs as they are released, says Adrian. The oviducts release lots of eggs into the water column, which hatch into larvae. They then settle on nearby bones or can drift to another whale carcass. These small scavengers can spend as long as 10 years harvesting the remains of a whale. While scavengers are at work digesting the bones, for 10 to 50 years the whale fall provides for a more specialized set of feeders. The bones are taken over by bacteria that produce hydrogen sulfide, a gas that smells of rotten eggs. A process called chemoautotrophy is a way for animals to gain energy through this and other chemicals rather than through food. Specialized mollusk and tube worm species are chemoautotrophs that take advantage of whale falls, feeding on the chemicals released from the bones. Before whale falls were well documented, it was thought that this type of biodiversity was only seen at cold seep sites and hydrothermal vents, where hydrogen sulfide and methane naturally escape through the sediment. But it is now acknowledged that whale falls offer a unique stepping stone for specialized animals from these sites to disperse across the predominantly desolate ocean floor. Not all whales sink to the bottom of the ocean when they die, however. Some instead become stranded on coasts around the world. Although efforts are often made to save them, without water to maintain their buoyancy, the weight of the whale's own body soon begins to crush the internal organs. As smelly as 100 tons of decomposing flesh can be, a beached whale is a scientific goldmine, an opportunity to study a creature that is frequently beyond reach. The museum has been actively involved in the UK cetacean strandings investigation program since 1913, collecting information on the ocean giants that wash up on UK shores. The primary goal in studying a stranding is to gather as much biological information as possible about the whale itself. Because happening upon a natural whale fall is so rare, scientists can use the opportunity to take and strategically sink parts of these animals to help improve understanding of the process of decay. Whales are exceedingly important in the marine ecosystem. They are efficient feeders, sitting high up in the food chain. In death, they provide life for hundreds of marine animals for up to 50 years, further proof of the vital role they play in the life cycle within Earth's oceans. And despite the potential loss of species, some perhaps yet unknown, scientists expect to discover more connections between the behemoths above and their graveyards below. And, says Dahlgren, for people looking for additional reasons to save the whales, this is one, a clear connection between the number of large-bodied whales and marine biodiversity.